Is the screen visible?
Yes, sir.
Oh. So last class we discussed about labeling connected components, and as I told you already, this helps us in fact identifying the shape of a region, so that if you label it, it also helps us in doing segmentation, because when once you label, you can decide to what category that belongs to, and you can take a decision depending on whether that region would be of interest to you. Then we call it as the foreground region, and if it is not interesting to you, that will be the background. See, those of you who have already done completed the course on this MATLAB image processing on ramp on MATLAB, I think probably you would have understood what I meant by foreground and background. The problem there is to identify the text region and decide whether the given image is a receipt image or not, depending on the text. So the text will be the background when you want to detect the text region, and so by just seeing this text, you will decide whether it is belonging to a maybe a receipt image or it is not a receipt image. So here you can observe uh, we do what is known as in fact, a raster scan for 4 connectivity, and assuming that the image is a binary image, and the value v is given to be 1. That means all pixels with value 1 has to be labeled. So what you do, you just scan the image pixel by pixel from left to right, and of course from top to bottom. And then when you are at a position, if p is the pixel at that position, because it is 4 connectivity, you would have already labeled r and t. In the last class, I showed you which is the r pixel, which is the t pixel, which is your upper and left hand neighbor of p. Because you have already labeled these r and t, now you are trying to label p, and depending on the value of p, okay, you decide what should be the label given to p depending on r and t. So that is the scan. So if p is 0, you don't need to label it, because you are labeling only pixels with gray level 1. If p is 1, then you check r and t. If both r and t are 0, then I assign a new label, and so on and so forth. So this is the algorithm. Quickly, let us just try to see this problem again. uh, I'll just go back to the problem. So let us just try to solve this quickly, just to refresh what we have done. Okay, is the OneNote screen visible?
Yes, sir.
Okay. So if I start from left to right, so the first one, I'll just start with L1. Just reduce the thickness. Okay. So the first one is L1. Then the next one will also be L1, because you are when you come to this position, you have to only see this position, because this pixel is absent here, because that is a border pixel. So that will also be L1. The next one is also L1, you know that, because you are only looking at this pixel and assigning it. So then the next is 0, just leave it without labeling it, because you are labeling V equal to 1. Then the next one you have to label. As you can see, this label is 0, or this is 0, so definitely you have to give a new label to this. So that new label, I'll give it as AL2. Then when I come here, this position, the only pixel that is labeled is this, because this is missing here. It's a border pixel, so this is missing. So I'll just label this as L1. This is L1. Then this 2 will be 0, and this will be L3, because you can see when I come here, I have to look at these two labels. Both of them are 0, and by the algorithm, when both of them are 0, you have to give a new label to this. So give it as L3. Now when I come to this position, let me delete all these things. So when I come to this position, you have to look at these two. And if both are same, then you don't have any ambiguity. But in our case, both are different. One is L2, other is L3. So as I told you, give one of them, and don't forget to write L2 is same as L3. So this is because this will be considered in the next pass. Then again next row, this is L1, this will be L1, this will be L1, this is 0. And here I have to look at this and this. Since only one of them is labeled, I have to assign that label here. Then this is 0, this is 0, this will be L1, this is 0, this will be L2. This is a new label now because this pixel is 0, this is absent, therefore I have to give a new label, so let me call it as L4. So this will be L4 again because uh, this is already labeled as L4, so I have to copy that. This is 0, this is 0, and this will be L2. So this is the first pass. And as I told you, the second pass you have to consider this. This condition has to be considered. That means L2 is equal to L3. Okay. So whichever is L2 and L3, you can just call this by another label. So I'll just call it as L2 itself. So that means L3 is same as L2. So this will be L2 now. Okay. Now L3 is missing. So instead of calling this as L4, I can even call it as L3 because it is better to call them sequentially. Now the new label, sorry, the label would be like this. Okay, instead of calling L1 L2, I'll just call them 1 and 2 3. So this is 0, this is 2, this is 1 0 0, this is 2 2, uh, this is 2, sorry, this is 1 1 1 0 2 0 0 1 0 2, 3 3 0 0 2. So this is the label. So you can observe here these pixels will have the same gray level. So this would be called as say one region here which has got gray level equal to 1. I'll have another region where the value is equal to 1, that is this region. I will have another region. So these are the three now regions which are of your interest. That means you are looking for example, I'm looking for say water region. Assume that when I convert my satellite image into a binary image, the water region takes a value equal to say 1. So what you see now is the water region, and 0 will be the background, and this region that is marked here will be, that means this will be the foreground for you. So like this I can use it to identify a region according to the requirement. Now let us try to do second um, for 8 connectivity. Thickness is more. So I'll do it for 8 connectivity or 8 adjacency. Now if you carefully observe, when I am just doing a scanning like this, when I do a scan like this, what happens is I would have labeled, see I'm somewhere here, say, assume that I'm somewhere here. So you would have already labeled this, you would have already labeled this, you would have labeled this, and you would have labeled this. Okay. See, in the previous case, I was only considering in 4 connectivity, I was only considering these two. But now since this is 8 connectivity, these are also 8 connected pixels. These are also, sorry, these are also 8 neighbors. This is also an 8 neighbor. So now I have to consider 2 more pixels. So totally when I am labeling this pixel, I should look at what are these values. Okay. So I think in the algorithm, he is calling them as, we'll go to the next slide. So he is calling them as Q, R, S and T. So let me just use the same thing. Say this is Q, this is R, this is S and this is T. So when I am labeling P, I should look at Q, R, S and T and take a decision. How will you take a decision? Observe. Suppose if P is 0, there is no ambiguity because I am labeling all values V equal to 1. So you move to the next position. If P is 1, then examine Q, R, S and T. If all of them are 0, as usual, assign a new label. If only one of them is 1, you have to assign that label to P. If two or more neighbors are 1, assign one of the labels to P and make note of the appropriate equivalent classes. Okay, so if you have two or more neighbors as 1, and assign one of the labels, because they would be labeled differently, so assign one of them, but make sure that they are equivalent classes and repeat it in the second pass, you will get it. So let us just try to solve this problem now. Okay, I want one of you to please respond, help me in okay. Okay, so the first one is L1, no doubt. Second one is definitely an 8 neighbor of first one, and both of them are 1, say therefore this is also L1, this is also L1. Next one is 0. Next one should be given a new label, so I'll give it as L2. Now this is L1, this is 0, this is 0, and this is 1 now. What should I do now? Can somebody tell me? I am here. What label I should give?
Sir, we can give L1 or L2 and
Correct.
assign it as L1 equivalent.
Very good, very good. So I can give it as L1, and don't forget to write L1 is same as L2. Very good. Fine. And this,
L2, sir.
yeah, I can give it as L1 also, because
Yes.
already L1 is written as L2. So I can call it as L1. Okay. And L1 is equal to L2, equivalent class is already written. Now when I come here, this is L1 again, this is L1 again. And what is this? This, you can observe that this is labeled, this is labeled. Of course these two are zeros, so both of them are L1 only, so I have to copy L1 here. This is L1. Now this is 0. When I come here, I have to look at these two only, these three, 1 2 3. Both of them are L1, so I'll put it as L1. Now this is 0, this is 0, this will be definitely L1, 0, this will be L1. In fact, it's an easy thing, and this should be given a new label. So this is L3, and this is also L3. uh, one second, one second, this is not
So
L3.
that is L1.
Correct, 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 because you have already labeled this. This is labeled, so when I come here, I should look at this pixel, this pixel, this pixel, and this pixel. These two are labeled. One is L1, other is L3. So I'll write it as L1. And what you should do, you should now say L1 is same as, L1 is same as, somebody respond. Yes,
L3, sir.
L3, correct. Okay, so, okay. Now this is 0, this is 0, no ambiguity there. So it is L1. Now this is the first pass. In the second pass, you have to take care of these equivalents. So whenever there is an L2, you can call it as L1. So let me use a different color for this, just to make sure that I am using the, okay. So this will become L1. Sorry, this will become L1. And L1 is also, L3 is also same as L1. So this is also L1. So notice here, in fact, there is only one label now. And this is the region now. Just carefully observe. Sorry. Carefully observe. Is that correct? Whatever you have inside this contour is L1. The outside, the other one is background. Okay. So how many labels are there in this?
One label.
Only one label. So let us try this on MATLAB. The only change you have to do is you have to give 8 here. Okay. So, okay, let me just, so I have to give 8 here and run this. Okay, observe, this is the image, and after labeling you can see there is only one label, so n is equal to 1. Okay, is the point clear?
Yes, sir.
Okay, fine, good. Okay,
Sir,
so
can you please explain why L3 is equal to L1 once again?
yeah, okay, okay. So I was here, right? I was here, I came here, and this, to label this I have to look at this one, this one, this one, and this one. This is correct, right? Correct, no?
Yes, sir.
Okay, so you can see that these two are zeros, these are border, so you don't have, so definitely I have to give a new label here. Is that correct? When you come here, give a new label.
Yes.
Now when you come here, what you have to look, you have to look at this. I hope my markings are clear. You have to look at this, you have to look at this, and you have to look,
Yes, yes.
okay, so this you have labeled L1, okay, and this you have labeled L3. Okay, so when there are more than two labels, you have to assign one of them here. Okay,
Yes.
either I can assign it as L3 and say L3 is equal to L1, or assign it as L1 and say L1 is equal to L3. I hope my point is clear.
Yes. Yes.
Okay, fine. Okay, I will not explain the rest other thing for the gray image, but completely, but I think concept is same. Let me just take a gray image. Let me just take some values like this. I will not completely explain it. I only want you to try this later. Okay, let us assume that this is an image and I want to label. What else I should give you? I should give you V. So the only change here is V should be given in the range of whatever you are interested in. Let us assume that uh, it's a gray image, and water region in a satellite image, let us assume that it takes the gray level from say 10 to 15. I will just make an assumption, 10 to 15. Okay, so let us make an assumption. Now this is all the change. So what the rest is same. You have to do raster scan left to right and look at the pixels and start labeling them. Okay, so what does it mean? Let me just do it for maybe the first row. Okay, so the first one pixel is 12, so 12 belongs to this set V2, sorry V, so first one will be L1. What will be the next one? Can somebody quickly tell me what will be L1? Sorry, what will be the
L1.
next? L1. What is the next one? 15?
L1.
L1, because it is in the range. 16?
L2.
No, no, it is not in your V. If it is not in your V,
J2.
you just call it as 0. 18 is 0. That means the label is 0. That's the meaning. Value is not 0. The label for that is 0. This is 0. For 16, it is 0. For 12, 12,
L1.
L1. Very good. 13,
L1.
L1. Correct. L1. And this one.
0.
No, no. That is in the range 10 to 15.
Sir, it is not connected for
No,
L1.
no. It's a new. See, this value 12 is a new value. Okay. So you
Yes.
have to look
L2.
at this and look at this. Since it is a new value and these values are not assigned, so I have to give a new label here. Correct. This is L2. Now what about this? What about this? Quickly.
L1.
Ah, yeah, you can write
L1
it
equal
as
to L2.
L1, L1 equal to L2. Okay. So like this you can continue. I'll not do the rest. Like this you continue, and similarly you do it for 8 connectivity. Okay, for want of time I don't want to take it. I just want you to understand the concept for 4 and 8 connected component analysis. Okay, I'll assume that this is understood. Whatever code I have shown here, I want you to develop this code. Don't use BW label and do it. Given an image, don't do it for okay, binary image. For an image like this, again something happened here. Okay, it's okay. For an image like this, for an image like this, I want you to give the labels. Definitely you cannot give it as L1, L2, you give it as 1, 2, 3. Okay. So I'll be happy if any of you develop a code for a general image where the algorithm will take V as the input. Okay, I hope you are understanding. The algorithm should take V as the input, what range you want to define, and then pass the image two times on either 4 connectivity and 8 connectivity. You should give me the okay, the levels. Okay, so do this in the lab sometime, and if any of you share this program to me, no, I can discuss it in the class later. Okay, so that is about 8 connectivity. Yeah, so the next concept is simple, nothing great here. We see, once I label, I get a region. Suppose I am interested in finding the probably the length of that particular connected. In fact, sorry, the length. Let me just uh, okay, explain it in a simple words. Again, I started getting this problem, but it's okay. I can manage it. It does not waste time. So assume that I have a satellite image. Assume that this is a satellite image. Now assume that there is some water here. Okay, this is water, some tank, water tank or whatever it is. And now assume that there is a city here. Okay, suppose if maybe some canal has to be dug from here to here. Government wants to find what is the length, or sorry, what is the distance of this point to the city. Okay, this distance has to be measured. Another example I'll give you. In fact, you are regularly using it. When you just okay, use Google Map, you normally click on one position and you click on other position that you want to travel. So it actually tells you what is the distance that you need to travel. Okay, the physical distance. So to determine this physical distance, okay, there are different distance measures. So now we want to discuss that. I'll just explain the nomenclature. So assume that there are 3 pixels, P, Q and Z. P is of coordinate x comma y, Q is of coordinate s comma t, and Z is of coordinate v comma w. Now you want to measure the distance, okay, from some position to other one, from some pixel to other pixel. So actually, this distance definitely should be greater. It cannot be negative, obviously. You cannot have negative distance from one point to other point. It can be zero, of course, but it cannot be negative. This is in fact a common sense okay point. Now, suppose if both P and Q are same, definitely the distance is zero, obvious. Okay. Now, distance from P to Q is same as distance from Q to P. That's also an obvious thing. Distance from Bangalore to Tumkur is same as distance from Tumkur to Bangalore. There is no difference, obviously, unless and until we follow a different path. Anyway, here it is just the physical distance. Now, if we want to find distance between P and Z, usually it will be less than or equal to the distance from P to Q plus distance from Q to Z. Okay, so this is a simple metric which follows the conditions. Now there are 3 distance measures. The first one is Euclidean distance. By definition, Euclidean distance between P and Q is x comma y is the coordinate of P, s comma t is the coordinate of Q. Remember that. So it is x minus s square. That means x coordinate of first pixel, x coordinate of the second pixel. So x minus s square plus y minus t square under root. Okay, so it is something like this. So if I have a pixel P which is having the coordinates as x comma y, and another pixel Q which is having coordinates s comma t. So Euclidean distance is square root of x minus s square plus y minus t square. Okay, this is Euclidean distance. Remember, you are only looking at the coordinates x comma y and s comma t. You are not looking at what is the value at p, what is the value at q. That means the gray level is immaterial to me. I want the physical distance. Okay, I hope you understood. Fine. That is called Euclidean distance. And another distance measure called d4 distance. It's also called city block distance, which will give you this. Okay, it is x minus s modulus value, absolute value. That means even this value becomes negative, you take the positive of that, plus y minus t, absolute value. Let us take an example and do this later. Okay, so this would be the distance x minus s modulus plus y minus t. Now suppose, see, I have a pixel p here. Now let me assume that d4 distance is equal to 1. Okay, definitely this pixel has got a d4 distance from p equal to 1. This pixel has got a d4 distance from p equal to 1. This pixel, that is this and this pixel, all these 4 pixels will have d4 equal to 1. Now let me assume that I want d4 equal to 2. Observe now carefully, d4 is equal to 2. See this pixel, when I want to go here, I will traverse one distance here, and I'll reach. So d4 distance between p and this pixel is equal to 2. Okay. Again, this pixel will have d4 distance equal to y, because I want to, because it is d4 distance. Be very careful. I want to go one pixel like this, one pixel like this. Again, this pixel will have d4 distance equal to 1, because one like this, one like this, again one like this, one like this, and these are the pixels. And what else? This pixel has got two distance, because one here, one here. Okay, this pixel has got two distance. This pixel has got two distance, one here and one here. This pixel has got two distance, one here. Now notice this shape. So all pixels whose distance d4 equal to 2 lies in this region. This is all pixels whose distance is equal to 1 lies in this shape. Okay, that's exactly what is written here in the okay. Pixels with distance less than r can be 1, 2, 3, etc., form a diamond centered at x comma y. So this is the diamond shape I am talking about. Is the point clear?
Yes, sir.
Okay, fine. The next one. Notice that this is square root of x minus s square plus y minus t square. So definitely this can be a decimal number. You can have fractions also here. Okay. Whereas here you are just subtracting the pixel coordinate and taking absolute value. So you cannot expect definitely fractional values here. It will be an integer value. Next is d8 distance. Okay. The difference between d4 and d8 is this. Here it is not x minus s plus y minus t. It is actually x minus s comma y minus t, maximum of that. That means if this is more than this, you will take that, and that would be the d8 distance. Let me just take an example. So I will just take maybe a pixel, say 1 comma 1. Okay, and I want to find d8 distance between a pixel, say 2 comma 2. So as by definition it is max of 1 minus 2 absolute value, 1 minus 2 absolute value, maximum of this. So 1 minus 2 absolute value is 1, 1 minus 2 absolute value of 1, maximum of that is 1. So d8 distance between these two pixels is 1, sir. Okay, d8 distance is 1. That means these two. So definitely even these two pixels will also have dI distance equal to 1. These two pixels will also have dI distance equal to 1. Even these two. So as you can notice here, all these pixels that I am showing, they all have dI distance equal to 1. So that's exactly what is written here. Pixels with distance less than or form a square centered at x comma y. So this is a square region. This is a square region. Whereas here it is, you can see the diamond shape. Okay. So this is how I can find Euclidean distance, d4 distance, d8 distance. Euclidean distance can take decimal values, whereas da4 and d8 distance will take only integers. Okay. Euclidean distance, sorry, d4 distance is also called city block distance, and d8 distance is called chessboard. Why? Because assuming that it is a well planned city, each block in a city will you have to go from one block to other block by only passing through a proper region. Why? What I mean is, that is why in the beginning only I said well planned region. Okay, is the screen visible? Uh,
Yes, sir.
okay, see, assume that these are the different blocks. Okay, and assume that this is a road in a city, well planned, I told. Okay, different road. This is some third class, this is from fourth class. Now suppose if I want to move to this block, you cannot go like this. Okay, there cannot be a path like this. So I should first go like this. I should first, then I should go like this, or I should go like this, I should go like this. This is the reason why I told it should be a well planned city. It doesn't okay, uh, in fact fit to cities where it is not planned, where you can have all these okay, crossroads, dead ends. Yeah, I hope what I meant. Okay, so this is the reason why it is called city block distance. So this cross connectivity is missing. You cannot have this cross connectivity. This cannot have. Whereas in a d8 distance, it is chessboard, because you know in chessboard you can move from any okay, block to any block. I think those of you who have played chess understand it better. Okay, so the movement, of course there are some restrictions, but you can move. Okay, so let us just try to solve a simple problem on this. Assume that I have a 100 cross 100 image. I have a 100 cross 100 image. Okay, so this is a 100 cross 100 image. I am interested in finding, let me take the topmost corner pixel as P, the rightmost corner pixel as Q. So now I'm interested in finding Euclidean distance between P and Q, D4 distance between P and Q, and D8 distance between P and Q. Okay. I'll give you 2 minutes time. I want you to solve this problem. Okay. I think you know the definitions, or if you want, I can show that. So the definitions are here. And first thing you need to do here is first see what is the coordinate of this. What is the coordinate of this? Okay. Can I get the answer from you? Whoever does it, please tell me the answer. Okay. Anybody with the answer? Hello.
solving, sir.
Pardon?
Still solving, sir.
Still solving. Any one of them? Okay, you can just tell me if you are done. It should not take much time because you know the formulas and it's a straightforward substitution. Anyway, solve it. It's okay. Anybody who has solved Vikas M, are you there? Vikas M.
Yes, sir. Yes,
Oh,
sir.
yeah. So have you solved?
Just solving, sir.
I don't know why it is taking so much time, but anyway, let us not waste our time. Uh, what is the x coordinate here? Can somebody tell me? X comma y for p. What is x comma y for p?
Sir, 0, 0.
0, 0. Okay, so you want, okay, then what is x comma y for q?
100, comma.
Pardon?
100, comma 100.
100 comma 100. So I think that is the reason why I didn't solve it, because I know this mistake will be done. Will it be 100 comma 100 or 99 comma 99?
99, comma 99.
Yeah, so that is where you may go wrong. Otherwise it is simple. Okay, so this is what you have to be very careful, because it is 100 cross 100 image. So if you start at 0, it should be 99. Or you can do like this also. If you start at 1 comma 1, and what Rahul told is correct, it is 100 comma 100. So 1 to 100, 1 to 100 rows and 1 to 100 columns. Okay. So anyone you can use, both of them will yield you the same answer because you are taking subtraction. So obviously. So the Euclidean distance will be, I will use the first one only, 99 minus 0 square plus 99 minus 0 square under root. I calculate this under so many pixels. That is the answer. Okay. Then the next one is 99 minus 0 absolute value of that plus 99 minus 0 absolute value of that. So this will be 198. The next one is maximum of this difference, which is 99. So many pixels. Is the point clear? How we can calculate distance between two points in an image?
Yes, sir.
Okay. So I think in the lab, probably this I asked in the previous cases also. Let us assume that I have a pen. You have a pen, or any object for that matter. Assume that you have a pen and you want to measure the length of this pen. Okay, the length. So what I want you to do is you should keep your pen on the table. Uh, Capture an image of this by using your mobile camera. Okay, capture an image using mobile camera. But before doing that, you need a calibration. Okay, what I please listen to this, because this is an interesting problem. You can do it on a sheet of paper. Keep your pen. Okay, then on one corner just draw a line of exactly say 1 centimeter. This is for calibration. You draw a line for 1 centimeter. Now you have to capture this image. There is a pen kept on the sheet. and keep it horizontally, because I want one of the coordinator to be 0. So this is a line of length 1 centimeter. Now what you need to do is you should click on this position. There is a command in MATLAB called G input. Okay, so if you just run this command, click your mouse on one corner here, it will give you the x and y coordinate of this. X and y coordinate of this. So I'll get x comma y of this. Click on this point, you will get maybe s comma t. So definitely you can find your Euclidean distance by using the formula. Now you will get it in pixels, but I want this in centimeters. Okay, so you should know each pixel is how many in centimeters. That is why this calibration. So what you need to do is you have already marked 1 centimeter line. So click on this, find its distance, that you will get it in pixels. Convert that pixels into into centimeter, because you know this is 1 centimeter. How many pixels, you know? So 1 centimeter is equal to so many pixels, and use that to calibrate your Euclidean distance here. Okay. Did you understand what has to be done? An interesting thing, if somebody does it and verifies it physically, you can just demonstrate it in some class. Okay, is the the step clear to you, what you need to do?
Yes, sir.
Okay, so this concept is used for see what is the use of this. For example, you know, you have determined an object, assume that it's an ultrasound image, and I have okay, identified that there is some okay region which is of interest to me. Now what I can do is I just want to see, because you know doctor has to take a decision what is the size and all. So if I just click on this and maybe click on this, maybe click on this and click on this, I'll roughly get what would be the area of this, roughly. In fact, inserting a square on that, or rectangle, whatever it is. So I can just find what would be the size of this okay, problem that I have in some ultrasound scanned images, or whatever it is. Or it could be maybe some fracture in the bone. So there is some fracture here and fracture somewhere here. So I'm interested in this length, so that I would like to know what should be the length of the rod that you might insert. Whatever may be the application, I can use this simple image processing concept to in fact distance measure to measure it. In fact, I can give you one more application which was given to us as a project by civil engineering department. After the buildings are constructed, in fact they are the huge buildings, so you will have multiple floors. Assume that this is second floor, this is third floor. Now you need to make measurement of this. So once you build those huge structures, finding the area would be very difficult. Maybe you have to pay the contractor the amount, so I need to find this area. You cannot physically go back there and do the measurement. What you can probably do is, if you use some calibration, you can just capture an image and try to find that area by just using image processing. I can definitely find okay what could be the area that is covered. So there are many applications of this. You want to find size of an object, this concept could be used. Okay, so that is the use of distance measures. There are, in fact, there is one more distance called dm distance, but the only difference is dm distance, it is going to look at the gray level values in the position. Okay, so d4 d8 distance, it depends only on the xy coordinates. It will not look at the gray level value, whereas dm distance, it will look at the gray level value. Okay, so you know that when you want to find the m connectivity, you have to look at the neighbors and just see whether the intersection is a null or not. I hope you remember. So with that, let us just try to solve this simple problem. I hope I still have time. Yes, we still have 10 minutes time. Let us do it. So let us assume that I have a pixel arrangement like this. So this is P, P1, P2, P3, P4. I'll just solve it. So this is P, P1, P2, P3, P4. Okay. The first case, of course, V is equal to 1. The first case is P, P2, P4 are 1 and P1 and P3 is 0. So P, P2 and P4 are 1. This is 1, this is 1, this is 1, this is 0 and this is 0. Now, with the definition of M connectivity, can you tell me whether these two are M connected, 1 and 1? Are they M connected? Would say yes or no.
Yes, sir.
Yes, they are M connected because one is a, in fact, this is a diagonal neighbor of this, and you can observe that this value is 0. So definitely the common neighbor is not there. So definitely these two are connected. These two are M connected. So what is the length? Distance 2 pixels. Okay. This is the first problem. The next what he says is, sorry, P, P2, P4 are 1 and P1 is also equal to 1. Okay. So in the next case, P1 is also 1. That means this is also 1. 1, 1, 1. This is 0, but this is 1. Okay. I think so written. So let me just remove this. So 1, these three are 1s. This is 1, but this is 0. Now tell me, are these two M connected directly?
No, sir.
No. Why? Because this is 1. So the connectivity is like this. It should go like this. You cannot show this path. This path is missing. This cannot be there. Okay. This should not be there. Okay. And of course these two are M connected because the this value is 0. So these two are M connected. So what is the length? 1, 2, 3.
3.
Now, okay, this is what it means. So I think that is a moral. So dm distance between two pixels is defined as the shortest m path. It depends on the values of the neighbor. So dm distance looks into the values, whereas d4, d8 and Euclidean distance never looks at the values. It only looks at the coordinate, sorry, the x and y coordinates, and it's a physical distance. Whereas here it is whether they are connected or not. That is the difference. So similarly, actually for other cases, this can be done later. So I'll just skip this. Okay. So this is about the distance measures. So we have talked about four different distances: Euclidean distance, d4 distance, d8 distance. Euclidean distance can have decimal values. d4 and d8, of course, dm also will have, in fact, integer values. And dm distance looks into the values in the in the position, whereas other d4 and d8 doesn't look into values. Okay. This is just a okay, just to wind up. In fact, this is uh, just an introduction. We may not discuss in detail. Most of the operations that we do on images will be either array operations or matrix operations. That means since image is a matrix, I perform matrix operations. Then the operation that I'm going to perform may be a linear operation or a non-linear operation. Okay. For example, if I take the pixels, average them in a region, that becomes a linear operator. Instead of averaging, if I use a median of that, or maybe mode of that, it becomes a non-linear operation. And all of you know what do you mean by non-linear linear operations. Okay, it should satisfy this condition. That means the operator, whenever I just multiply by a constant and do superposition, you should get back this. I think linearity is known. Actually, a sum operator, as I told, is a linear operator. There is an operator called max operator or min operator. In the next chapter, we are going to discuss about this. It is a non-linear operator. Now, images can be added. Images can be subtracted. Of course, they can be multiplied. They can be divided. So you can perform all these arithmetic operations. Without spending much time, I'll tell you what is the use of each of this operation. First operation is addition. See, normally when I capture an image using a camera, for example, a satellite camera, it is always true that the noise is going to get added. How do I remove it? There is a simple case. Instead of taking one image, just average some k number of images. Okay. How do I average? I add all the images. So you have addition operation has come here. So add all the images and divide it by the total number of images. So when you take an average, obviously, when I take an average, any shoot up that you will have gets removed, because mean of this noise is usually 0. So when you average images, noise is going to be nullified. In fact, that is demonstrated in this image. After averaging some 100 images, noisy images, you are getting an image which is noise free. Image subtraction, when you want to find the difference between two images. So you have arrived at some result and you want to know whether you are very close to the original. You can subtract them and see what is the difference. In fact, a very good example is given. For example, there is uh, in angiography you have what is known as masking here. Angiography, what they do is they'll actually inject a color dye to the body. Before injecting the dye, they will take an image. After injecting the dye, they will take another image. So this color dye will move through the, uh, probably the uh, nerves, and whenever there is a blockage, so when I take the difference, there you would see the difference at that blocking position. So in fact, this is the difference that is being shown. So you could see that there is some blockage here. Okay, this is how subtraction could be used. I can also use this to find difference between two images. For example, I want to know whether there is any motion from one frame to other frame. Just subtract them. There is a difference means then there is okay. Uh, there is some motion. Otherwise, there is no motion. So multiplication. This is an application. See, for example, this is a dental X-ray image. I just want to see only this region, not the rest of the region. So what you do is you multiply with this type of mask. White is 1 and black is 0. So what happens is 0 into anything will be 0. You can notice that here. And 1 into anything, you will get back that value here. So doctor can now carefully look at this region and try to take some decision. So I just want to introduce these applications, the operations. As I told, addition. Addition is used to remove noise in images by doing averaging of n number of images. Subtraction could be used to find difference between two images. That means what is the change from one image to the other image. And one of the application is in angiography. And multiplication could be used to probably localize or get a region of interest from an image, full image. This is the region of interest. Okay. Uh, I think this is just to understand. Whenever I perform some okay movement in the camera or in the scene, different types of spatial transformations take place. Identity means nothing happens. There could be scaling, there could be rotation, there could be translation. Of course, there could be some shearing. That means when the camera moves in an awkward position, I may have this shear. So scaling means what you did in the beginning, that is zooming or shrinking, that is scaling. So either I reduce the image or I increase the size of the image, that is scaling. Rotation, as you know, when the camera rotates by an angle. Okay, by, for example, in this case, theta is the rotation angle. So any transformation that happens to the coordinates will yield a new values of x comma y by doing a transformation on the original coordinates v comma w. Now this is represented in the form of different matrices. Okay, just refer to these matrices. We may not discuss this in detail. This is only to just understand that there are different, in fact, geometrical transformations that happens on an image. So as you can see, this is scaling. See, the original image is scaled up. The size is increased. This is rotation. So it is rotated by an angle theta, and the theta can be decided. And this is translation. That means it is shifted by some pixels, and this is shear operation. Okay. So this is how any geometric transformation can be shown as some matrix multiplication. Okay. So with this, we have completed the first part of unit 1. So we will consider the next part, which is image transforms, from next class. I just want you to give attendance. I'll just share the link for your attendance. So I think I have received about 34 certificates from you. Actually, there are 47 students in the class. So those of you who have not completed it, uh, complete it, because it's very important to complete this certificate, because that will also be considered for evaluation. So I'm just sharing the link. Quickly give the attendance, and those who complete the attendance can leave the class. B section students who have to attend lab today, actually you don't need to in fact log into the uh, Cisco WebEx. My requirement is you should actually work and then share the results to me. So you don't need to. I may not okay start the session, but I will be definitely verifying it in the next class what you have done during that period. Okay. Yeah. So those of you who complete the attendance can leave the class.